Good evening to all. Today, uh, in our class, we are going to discuss the Indian Railway Automatic Train Production System, that is KAVACH. This is a very important equipment as far as train working is concerned because it can prevent accidents, bad, and it can assist loco pilots in train working, etc. So it is a primary equipment which is of utmost importance as per railway board, and within few years it will be completed in entire railway network. So the version we are using now is KAVACH 4.0. Previous to this, version 3.2 was there. So based on this feedback in line, they have modified some aspect and released version 4 version, KAVACH version 4. Okay. Then KAVACH is a indigenously developed automatic train production system that is developed in India only. It provides protection of trains against PAD. PAD means signal passing at danger. It avoids collisions and also continuous updation of movement authority. So if this track view to LP is not clear also, in that conditions also, the signal aspect will be displayed very clearly. And the communication between stationary coverage and loco coverage, this is a protection level, integrity level 4. It has been certified to avoid unauthorized access. These are the governing specifications. This is the main specification issued by Signal and Directorate of RDSO. Then functional requirements as per this letter, then sister requirements and pre-commissioning checklist. In our shed, we are following this. After installation, this pre-commissioning checklist, what are the checkings we have to do? That has been specified in the specification. Based on this only, we are testing and giving it. These are the approved suppliers of KAVACH. Because there is no approved suppliers, all are developmental only. From this, 3 suppliers has been given for first lot. That is HBL Engineering, Kernex and Meda. As of now, these 3 suppliers are supplying to entire railways, but these are the developmental suppliers whose product has yet to be certified. In our shed, we are having only Meda. These are some of the features of the KAVACH. It is designed to allow the safe movement of train vicinity in northbound block section. To assist loco pilot by applying brakes, head-on, rear end, and side collision. In addition to this, these features also KAVACH will monitor prevention of overspeed, loop line speed control, computation of train length, on blowing out of LC gate, etc. These actions KAVACH will automatically perform without the intervention of LP. This is the basic architecture. In our loco, we are having onboard KAVACH. Like that, station will be having one stationary KAVACH. Communication will be happening between these two, onboard KAVACH and station KAVACH. Not only that, if in block section, communication can happen between loco to loco also, because station will be far away in block section. That time, if communication details are available with station KAVACH in this onboard KAVACH, then these two locos in a block section can communicate between themselves and can prevent accidents. And also station to station communication will be also there. All the events captured, whether it is in onboard KAVACH or stationary KAVACH, they are all logged and communicated to network management system. That is a server which is maintained by RDSO, and all the incidences related to KAVACH working are recorded in it. This is the overview of our system. The track share subsystems consist of RFID tags. So each track will be fitted one RFID tag. These, when loco is moved over this tag, one RFID reader will be fitted on the bottom side of loco, and when loco is moved over this tag, it will gather some information and it will transfer this to NMS server. And radio frequency identification. Then the portions of track including berthing tags, point and block sections are assigned unique IDs called track identification number. So whichever tags available in station or in other yards, etc., each track is given one identification number. So with this TIN number, we can identify whether the loco is in which track. System also consists of stationary coverage installed at station with radio tower to communicate. This is the basic concept of stationary coverage. Each station will be having an stationary coverage unit. It will collect all the signal aspect from interlocking panel, and it will transmit this to onboard coverage through radio communication. This already told. This route information, apart from this interlocking signals, route information that from SM panel, everything will be communicated, collected by stationary coverage and communicated to loco. This is the basic architecture, how communication takes place in a station section from station to loco. Okay, radio frequency communication will be there, and also this GPS communication. This is used for synchronizing time. And if loco goes to a block section, then it is already having this information which is collected from the last station and this loco. So with this information, these two will communicate between themselves. So it can communicate because this loco, each track is having, it will be having a particular identification number. So I am moving in this track. This loco also, I am moving in this track. So two locos, one track ID, TIN number. So it will be monitored by NMS server, and this through this communication it will stop like that. Like that, if after block session, it will go to another station. A separate stationary coverage unit is provided at mid-section interlock level crossing rate and intermediate boxing station if they do not come in the coverage of station data code. Because station to station different distance will be very much. So one particular station cannot transmit data to entire length of the track. So if that communication is not happening, means then we have to install one separate stationary coverage unit which will fetch from mother station and transmit to locomotives. That is for some boosting like that, conceptually. And the remote interface unit shall be used where remote signal functions are required to be fetched. Suppose if it is a LC gate, so LC gate signal, that signal from that interlocking panel, some signals and inputs, it has to be transmitted to the loco. For that, some additional unit, remote interface unit, we have to install, and with this, we will transmit the signal to loco. So these are the main track subsystems. So track installation, what are the equipments related to KAVACH? First one, RFID tag. So these tags will be installed in all the KAVACH controlled area. 1 kilometer, one RFID tag will be there. The distance between two RFID tags will be 1 kilometer. Then stationary coverage unit, already told station, it is associated with station. Throughout the track, RFID tag will be there. And tower and antenna. This is the tag. Like this, we have to provide in the entire KAVACH territory. Then only this KAVACH concept will work. These do not contain any active components. So these are the type of RFID tags. So different tags are assigned different functions. So normal tag means normal train track, normal working. Signal food tag means it will come before a signal. If the food tag is read means then KAVACH will came to know that signal is approaching, like that. Signal approach tag and tin discrimination tag. Each and every line, when this bifurcation takes place, each and every line will be having separate tin. So which track? Suppose if it is going in first one, then after sometimes it will separate to another route. Then that second route will be assigned a different number, tin number 2, like that. And LC gate tag, adjustment tag, and exit tags. Each is having different function. LC gate tag means if the tag is read means then KAVACH horn will be blown automatically. Some functions it has to do by identifying these tags. These are the main components of the station KAVACH. First, we will be having a tower, antenna, then a TICAS vital computer. That is the main our onboard KAVACH unit, like that. One unit will be there in station. Then this is the interfacing relay rack. All the signal inputs will be collected from this rack and it is communicated to main unit. Then there is a radio unit and SMOCP. Actually, station master will control this only. It is having an authorized operation. One key is there. He has to put, then only operation will take place. So these are the functions of station KAVACH. Collects the current status of all the field inputs, track circuits and berthing tracks, etc. from the SM panel and relay interlocking panel. Whatever data it is available there, it will collect and transmit to onboard KAVACH. So based on the status of input, station KAVACH calculates movement authority of the locos concerning the absolute position and routes set for those traveling in the station vicinity. So based on these inputs, what is the movement authority, up to what level, to what point train can work. That information also will be calculated and transmitted to onboard KAVACH as a movement authority. Movement authority means up to which distance, how much distance train can work. And also current signal aspect and next signal aspect. So not only this current signal, next what signal is coming. That also it should be, because train is working at so much speed. So next signal aspect also train driver has to get in advance. That also will be communicated. And all these communications and data transmission, synchronization, time synchronization should take place. That is through GPS. So these are the techniques used. First, radio communication, stationary KAVACH, loco KAVACH, and loco KAVACH, loco to loco. These are all communication taking place through radio. So GSM GPS communication is also there. So network server, because one server will be maintained, all the data and parameters, communication, whatever recordings available will be transmitted to management server, and wherever we can download. GPS communication for real time, already told, for time synchronization. These three modes of communications are available in KAVACH: radio communication, GSM GPS, and GPS. So we are coming to onboard KAVACH. Onboard KAVACH means what are the equipments we are installed in a locomotive. First we will have a OCIP. OCIP means driver display indication unit. Operation come indication panel. That is display unit. It is provided in both cabs. This is an RFID reader. This reader will scan this RFID tag and the position which it will automatically calculate. These are the two pulse generators. Normally, one pulse generator will be used for speed sensing. Here, two pulse generators are used because it is a direction sensor. It will also act as a direction sensor. If a communication is failed also, then it can calculate in which direction loco will move. Because if it is moving in this direction, this signal will be leading and this is lagging. So it is moving in that direction means that will be leading, this is lagging. For that purpose, two PGs are provided. And also radio antenna, GPS antenna on top of roof. Already told this one. These are the subsystems, our loco. Many KAVACH control unit, one number will be there. That is the main control unit. Then antennas will be there. Each antenna 2 numbers. Then driver display, driver machine interface. That is OCIP display unit. Radio control unit, RFID reader, sensors and isolation box. Sensors means pulse generators and BPBC sensors also there. This is our main control unit. It is located behind SP2 panel. Just like FDCS unit only, it will appear. These are our antennas used in the rooftop. 2 RF antennas and GPS and GSM antenna. Each cab will be having 2 RF antennas because that is the primary mode of communication. So these are the frequency range, operating frequency range. Radio frequency 406 to 470 megahertz. GSM 4G we are using 698 to 2700 megahertz, and also GPS 1559 to 1610. This is the main communication between the machine and the driver. It is called OCIP. That is the display unit. All the communication between KAVACH unit and driver will take place through this. So these are the major parameters in OCIP. First, loco ID. It will display what loco number. Target type. Target means if any restriction or LC gate or any stoppage driver has to do, so it will automatically collect the data from station KAVACH and it will display here. So turnout. Turnout means some separation, separate track turnout is there. So target type. This is the target turnout. So the turnout type like target distance. How much distance this target turnout is coming? It will be displayed here 1000. That means 1000 meters, 1 kilometer. In 1 kilometer, one target is coming. So this is the what is the permitted speed for the target. So he has to approach the target in 30 kmph. So that is shown as here, this dark green. Then all parameters it will display. Deceleration constant means if brake applied means then how much distance train will stop. That KAVACH will automatically calculate this one. Then this is the actual speed. How much train at present train is working. This is the maximum permitted speed in that section. How much maximum speed train can work. Section speed. This loco location. This location it will be based on the scanning of RFID tag. It will automatically calculate this one. Then it will transmit to different modes. At present, what is the mode? That symbol. This is the signal aspect. This is the movement authority. Up to what distance the train can move? This train is permitted to move up to 2 kilometers from the present location. Then these are the radio frequency communication status. The signal is available or not. Then radio frequency RFID tag reading. With the scanning, it will show as green. If it is missed means it will show as red. These are the driver selectable parameters. Radio control unit. For radio communication, separate radio unit has been provided with power supply module inside that radio unit. These are the RFID reader located below each cab. This is the primary equipment which scans this RFID tag. These are the power supply unit for that RFID tag. Speed sensors. Similar to our speedometer sensors only, but here we are having 2 sensors. Pressure sensors for taking pneumatic feedback. This is isolation box above the main unit. If driver wants to isolate the KAVACH means then he has to turn off the MCB and he has to operate the switch. It is called isolation box. So these are the interface of KAVACH with the pneumatic system. So each locus different names has been given. Conventional loco brake interface unit. It is called brake interface unit. Then E70 it is called interface relay unit, and CCB locos is called SIFA valve. So through this equipment only KAVACH will be controlling the brake. Controlling brake means dropping the BP. That's all. When to drop the BP and how to drop, that will be decided by the KAVACH based on the actual location and speed of the train. So this is the basic system working. This train is approaching this station. Already station is having all the signal aspects and the status. Already it is available there. So through this station antenna, it will communicate. Before communication, before establishing communication, secure communication to be established between station and KAVACH, because unauthorized access should not take place. For that, one key exchange should take place between this loco and station KAVACH. All this, because how this communication taking place, all the SIMs we are using here, it has been registered in that NMS server. All the SIM numbers and that SIM ID, all it has been registered in that NMS server. So through that NMS server only, if that SIM is registered in NMS server only, this communication can happen. Otherwise, if separate SIM, if you are changing one SIM in this loco, then it has to be registered in NMS server. Otherwise, this communication will not happen. So first it will check whether it is authorized or not. Then only communication will start. So it will communicate all the details. This onboard KAVACH will transmit the location direction. Which location I am coming? What is the location? Location means what is the RFID tag number? I am at which RFID tag? And what is my direction? That it will transmit to there. Then after this communication is established, this stationary KAVACH will send all this data to onboard KAVACH. This data transmission takes place, updation takes place every 2 seconds. Every 2 seconds, this communication will repeat. This is the basic overview. With this available data from stationary KAVACH, this loco will calculate a dynamic speed profile. So a static speed profile will be there, because in that section, what are the parameters, what is the maximum speed, and what speed it has to work. With that, it will evaluate a static speed profile chart. And at present, what is the condition? At present, what speed I am running? At what location I am running? How much distance I have to run? With that, it will calculate a dynamic speed profile. And these two will be compared. It should not exceed this static speed profile chart. If it is going to exceed or it this point will exceeds means then KAVACH will apply brakes. So these calculation will be done by KAVACH on its own with this data, static speed profile and dynamic speed profile. This will vary per second. Each and every second it will be varied. Each and every second this comparison is going on. So if there is a chance that this profile will exceed this point, means then braking application will start. Evaluate static speed with this data, na? With this data, this track interface, this track line, what is authorized speed, how much speed it is working, it has to work. At present, what is the speed? Like that, one speed profile it will make one chart. With this dynamic speed profile means each and every second this will vary, this dynamic. 1 second one data will be there, next second it will vary. So These data will be compared with both are by onboard coverage only because it is only moving. Na? Both are by onboard coverage only. This comparison will take place. This is to show that always this comparison is taking place. Both are by onboard coverage only. Stationary coverage is no. These are the different modes of operation. So total 13 modes are there. So what is the modes means what is the status of this coverage working at particular instant? What is that? So standby mode means first when we are switching on coverage, then it will be in standby mode. Like that, the staff responsible, full supervision, limited supervision. If it is working on its own, then it will be in full supervision mode. If suppose one signal is lost, if it is working in the line, so this stationary coverage and local coverage communication is lost, then it will go to limited supervision mode. Like that, there are different 13 modes. On-site mode means already that track will be occupied by some other train at some distance, but it will be cleared. With that time, he has to move. Then trip mode means if it is passed a signal, it has passed a signal at danger, then coverage will automatically apply brake. After that only driver has to move. Then he has to select the trip mode. Then post trip mode. After this mode, it will come post trip mode. It is speed restriction will be there. He has to watch and he has to move slowly like that. Reverse mode. Reverse mode means if it is for reverse movement of train. Shunting mode is there. No leading mode, system failure mode, and isolation mode. So at a time, at any instant of time, it will be in any one of these modes based on the working condition and track condition. Just one mode I have explained. This is the standby mode. So whenever we are switching on battery, it will be in standby mode. And when no cab is occupied, loco is power on and no cab is occupied means it will be in standby mode. Then it will do the brake test. Testing the brake means whatever the apparatus connected to coverage unit in pneumatic braking system, because the primary function of this system is to stop the train. So all the pneumatic systems should be connected and it should be evaluated that feedbacks are getting correctly. It can whether it can control this valves and whether that controlling is happening. That feedback also it has to get. For that only brake test it will do. Every battery on time or cap changing time this will happen. After successful completion of brake test only, KAVACH will start working. So after this brake test, it will prompt the driver to select this. Then we have to select which mode. I am going to work light engine or goods or passenger. What is the train we are going to work? We have to select. Then if you are selecting this passenger, then number of coaches, then it will automatically calculate the train length. And braking efficiency, always we have to give this as a range, a lowest range only, because otherwise chances of signal passing is there. So it what is this means? If it is given 85 means it will KAVACH will assume that this train is having poor brake efficiency. So this automatic monitoring will be high. Brake application will be it will automatically adjust to high mode. So with this inputs, the driver has to give passenger coaches, calculated length, braking efficiency. It will ask confirmation. Like that we have to do for goods train also. After this, it will be in standby mode. If when cab input is activated, BL key is put, then it will prompt to select staff responsible mode. Staff responsible means this KAVACH has not taken over the loco monitoring, but loco pilot has to check and move. He is permitted to move, but with his responsibility, that is staff responsibility. So these are the transition from different modes. First battery on time, it will be in standby mode only. Then Then it will go to staff responsible mode. This mode driver has to select manually. This dotted line means it will go automatically. The driver cannot select this one, this mode. So from staff responsible mode only, it will go to full supervision mode through limited supervision mode. So these are having different criteria. Staff responsible mode, when train started moving, then first it will read the RFID tag. After reading 3 tags only, radio communication will be established. And that condition also, it will go to limited supervision mode. Then it will move to on-site mode. And on-site mode, here it has to pass one signal in off condition. That means one green signal here it has to pass. Then only full supervision mode it will be going. Like that, different modes are there. These are the transition. From which mode it can go to which mode. Standby mode to shunt mode we can go. Staff responsible, limited supervision, automatic transition, full supervision. From full supervision it can go to override or reverse mode, trip mode, etc. So this is the major working mode of KAVACH, full supervision. It is supposed to work in full supervision mode always. Another feature of this KAVACH is that each loco provided with KAVACH can send a manual SOS. So SOS means danger message. Suppose if our train has derailed, some of our coaches are infringing other track. Then one train is coming in other direction. Then he is not knowing. Okay. So this train driver, which for what this accident has happened, he has to generate a manual signal, danger signal. So it will be transmitted to all other trains 3 kilometers radius. Then all the trains in 3 kilometers radius will stop working. The speed will come to 0, and after acknowledging, it has to move at a minimum speed 30 kmph up to the location where SOS has been generated. So it can be generated by either by station master can also generate SOS, and loco pilot can also generate SOS. SOS is cancelled only when who has generated the message has to cancel, or train is moved to more than 1500 meters from source, and no SOS repetition is there for more than 3 minutes. These 3 conditions only SOS will cancel. Otherwise, all the trains in that vicinity will be stopped. So already KAVACH is having counters provided to monitor all this. How many SOS has been generated? Suppose if any accident happens, then this will be cross-checked whether driver has alerted. He has to be alert to avoid further accident to other trains in that section. These are all recorded. So this is the power on procedure. First, we have to switch on these 2 MCBs in isolation box. Isolation switch should be in normal position. Then this interface relay unit, one switch and a coke will be there. It has to be put in service. This coke to be in service, this switch should be in service. Like that for CCB braking also. At present, leading cab. Previously, both cabs should be individual control. Now, only leading cab. Only. Yes. In the switch order. So these are the main modules available in our control unit. LTPS means power supply card, output card, input card, main control card, event log card, frequency card, CRD is counter card. This is the main control card. LED indications, what indications it is indicating. Input card. So these are the major inputs we are giving to our KAVACH unit, whether loco is leading or non-leading. Then SOS common, these are all coming from our display unit. Common SOS, SOS. This is if driver is generating SOS means the input will go. This which cab it is selected, which direction and isolation. If any isolation is all the inputs it will be sensing. Output card. Or 8 outputs only it is having. This is the major controlling of our KAVACH. 3 types of brakes: normal brakes, full service brake, emergency brake. How much brake pressure it has to go? Normal service brake means BP will reduce to 4.4 kg. Full service means it will reduce to 1.5. Emergency brake BP will drop entirely to 0. Then light engine mode, on it will control already this LC gate is there, it has to blow on. Traction cut off. If any braking is happening, then first it will cut off the traction. For that, output is also controlled by KAVACH. Frequency communication interface card, this is for communication. Counter module. These are the type of counters provided, whether number of times the loco, whether driver has intentionally isolated or not. Emergency brake, how many times emergency brake application has taken place? SOS generated or not? How many times? Even lower card for retrieving the data. All the data will be transmitted to NMS server and also it will be recorded here. Analog communication module for transmitting that BP-BC pressure sensor data to digital mode. Power supply card. 2 numbers are there. One will be in hot standby. So these are the limitations of KAVACH. KAVACH fails to protect a train when other train is a non-KAVACH train. Both locos are installed with KAVACH only, then only this system will work. Otherwise, cannot protect. There is no guarantee. Adequate braking resistance and speed is not available when a dangerous collision situation arises suddenly. Train derails and wagons, coaches dash with the other train already on this line. Because in this condition, driver can generate SOS and stop the train. But if already another train is there and the track means, then KAVACH cannot isolate that accident. Then failure of brake power. First, it will automatically calculate the brake power. If it is okay, then KAVACH will take over the charge. But if brake power of the loco during working, if some brake power pressure drop happens means, then calculated distance may overcome. In that condition, collisions may happen. Okay, thank you.